Here we are at Huston Precision. This is where we make and assemble all of the parts for the Apogee suspension module. Come on in. So CNC machine shop, kind of broken into 3 stations: inspection, mill, and lathe. And we can walk through and I'll show you what we make in each area. So CNC lathe, CNC just means that it's computer controlled motion. So we can program the part in the geometry we need, and it'll run that part repeatably every time. The parts we make on this are all of the round parts essentially. So the axles, here's some new prototype tension link axles that we're working on. These start in the lathe and then get finished in the mill. It's an old boy, so it still takes floppies. So I just got a new MacBook and I'm now running like 40 years of technology gap, you know, with like a USB-C to floppy disk adapter. Yeah. So CNC mill, the tool spins and then moves up, down, left, and right in order to cut through the material. Kind of like a hand router or like a wood router. See if I have enough air pressure to run it, but you can see, so the tool head moves up and down, and then the table moves in and out, and left and right. And through that motion, we can create really complex parts. So right now I'm just getting set up for the rockers. So these take input material, starts as a blank of material, do one side, finish it off, and then the second side fits in the pocket and we face off the material on the back. Yeah. This mill has also a 4th axis, so this can rotate, which means we can access multiple sides of the part. For some of our Apogee parts, like the knuckle, where we have complex geometry on the top and the bottoms here, as well as on these faces, we use the 4th axis to be able to access every side of it. This is the start of our knuckles, this hunk here. So these go into the mill and finishes that. So it starts out as this blank, not quite the same fit, again, because this is our early prototype geometry. Yeah. But starts out as this blank, goes in the machine, do one op on this side, and then flip it over and do a second op on the back side. So two setups. Pretty hard to do a part in one setup. Even like a simple lathe part like this, I've got to go from front to back to finish this diameter in the threads, and then flip it over and put the bolt in there as well.
So this was from one of our early prototypes.
Yeah, that's this.
From our V1 frame.
This is like V1.
Seen at Made in 2023.
Yeah, this is all 2023. So this is that's essentially our first prototype. It's kind of been through revisions now, and then once we get the new ones, I didn't even take the time to clean it.
You're so excited.
Just like threw it. Yeah, I was like, okay, get my stuff off of it and put it back to, put it up on the shelf.
That. But this is the original.
Yeah, this is the original, and it's kind of cool because essentially I like tell people anything that's not anodized, so anything that's this like shiny silver, is something that's been changed from our first designs. So it's kind of cool to look at it and just see some of the progression that we've had, and how we really did use this as like a solid test bed to try out ideas, to iterate on our design, to improve.
This has been 2 years in development now, I think is the big thing, right? Like a lot of people don't totally see that or don't know that whole story, that this has had a lot of thought and time and testing and engineering that's gone into it. And riding, I mean, you could see how dirty this thing is. Like, you've ridden the crap out of it.
One of the coolest things for me, and I was pointing out, like just outside, you can see the trails. Yeah. Like I like really strong memories. This change here, we'd actually updated the other prototype bikes with some new designs here, but we didn't make enough for my bike, and so this was kind of a last-minute design change before Sea Otter to get this bike riding again and make this part. And it was so cool to like spend a day in the shop, make this part, put the whole thing together, and then ride out the door and test it.
Yeah.
Really, really cool to like have that kind of like immediate access to trails and ride feedback.
So if you've bought a Founders Edition bike,
it's
your
gonna
parts
say
are gonna be on this rack.
it's coming out of this oven right here.
Yeah. And that's all in process right now, where some of those parts are here and have just arrived.
Yep, and some are in the
getting
machine
made.
this week. Yeah, exactly.
Super cool.
Yeah, so I kind of keep, this has been just like our assembly hardware.
All enduro bearings.
Yeah, all enduro.
Just sick.
I think like my background in building assembly lines or whatever, it's like I'm addicted to kind of organizing and trying to find good flows, and it's fun to just kind of keep evolving our process with the company as it grows. So this is kind of our tool, our critical tools for assembly, hardware, module. This area, this space generally kind of evolves. I try to keep the space really flexible. So this is kind of the Apogee cart. It's looking pretty light right now because we're in the process of building either out to Anno or getting machined the parts for the next round.
Let's talk about tubing.
Straight gauge 4130 steel. This is the top tube. So it comes in like this. It's 0.35 thickness, 1.25" diameter. So we take tubes like this and then we form them ourselves in-house to give this kind of elliptical taper from the top tube end out to a round section at the seat tube. Cool. It's something that we really feel is like crucial or critical to kind of the aesthetic of the bike. And so we've developed a process in-house to relatively efficiently bend them. So this was our 3D printed prototype. So this was just a plastic tool to kind of validate the concept. Our first ones were just done by hand in the vise, and we wanted to bring up like a process that'll give us the same tube every time. And then we've evolved it to a full-size die.
Oh, wow.
So the tube fits in. In the end, you can see it's machined to follow that elliptical profile with a taper out to a round section at the back. So this makes it round, that makes it flat, and so you can see if I load it, that slides down onto it. And then this I'm kind of proud of. This is like, one of the challenges is centering the tube in the flat area because there's not really much geometry to keep it in the same spot. And so this is like a retracting V block essentially. So this one's just 3D printed, but this V has enough spring force that it'll center the tube as the die closes. But then as you go down and smush the tube, it pulls up out of the way.
That's really clever.
Tongay or Tange tubes? I don't know what you're supposed to, was it Tongay?
I think it's Tongay.
Okay, we can call it.
Somebody's gonna hit us in the comments.
Yes, either way, whatever I say. If I say Tongay, you're gonna say it's Tange, and if I say Tange, you're gonna say it's Tongay.
Yeah. Okay, it's unboxing time.
Yeah.
So what do we got?
So these are rockers. These were kind of updates to some of the test bikes that we have. So these are our latest design. This is what we've been showing you essentially, but I just finished these up and then sent them out to Anno.
Yeah, so we were looking at the silver one earlier.
Yep, yeah, exactly.
And then this is what happens when it gets anodized.
Yep.
Yep.
Gunmetal gray. Machine shops are run on egg crates essentially, and it's really funny because I don't even think about it. And people then people notice them and they're like, can you edit out all the single-use plastic? If you've got extra egg crates, send them my way. I've got a stack, but I can always use more. Yeah, these are tension link. This is kind of just for fun. We were trying these without the blast, so you can see that these are a little shinier than like this part.
Oh, yeah.
Yeah, so I was just trying that as machined to see how they come out, since these are just like internal development samples.
Yeah. So one of the interesting design bits about this is previously this used to be hollow, right?
Yeah, it used to be two parts actually. Here's
2 parts. It is now 1. So if you had looked closely at some of the bikes that we brought to Made, there's this little gap in between here when you see it fully assembled. And in Bend we are seeing the dirt would
kind of build up there. You can kind of see it there.
Yeah.
I think
when we talk about reducing module to module, like 23 parts less from version 1 to version 2, and then as we're building our customer bikes, we're going lighter, simpler, even less parts.
The single piece is a more challenging machined part, especially like features like this where there's kind of this raised bump on this inner surface.
Yeah.
So that we need this to be able to get into the bearings, but clearance to the outside of the bearings. This is a little bit of a challenging machining path because you've got to kind of get a tool in here and relieve that. But once we figured that out, it really unlocked this design. So really happy with this. As you can see, like, we don't need a lot of structure in the middle here, but one of the challenges is like when you're finishing this part, out at the ends, if this thing was just wide open, these want to vibrate around a ton.
Yeah, you were talking about it being like a tuning fork.
Yeah, exactly. Yeah.
Yeah.
It already kind of rings a little bit.
Wow, yeah, you can hear that.
Yeah, and so like that ringing, when you like tap it with a vibrating tool, the whole thing just wants to resonate. So this was like a good, this is another example of like a really good like manufacturing and design collaboration, right? Where like understanding what our biggest barriers were to a single part design, which we both believed is better, and then like solving that from the manufacturing side with like an efficient process. And it's a bolted axle, so
it's even cooler now.
It looks cooler, compressed assembly.
The camera focus. That's sick. It's hard to, with the black, it's kind of hard to appreciate how nice of a piece that is.
There's nothing in the module except for the metal fasteners.
Even these little rocker bolts, Will and Colin are designing these themselves.
These trunnion bolts, these are all ours.
Okay, we got another box.
This is from our lathe partner down in San Jose. Yeah, here we go.
Wow.
So this is...
These are BB shells?
This is fun. This is our full customer bike shipment.
These will be going on Founders Edition
These will be going on Founders Edition bikes. So these are all of our bearing shells, our bottom bracket shells.
And these are cool because this is the part we're talking about here inside the side plate, of course. This is the BB shell threads into the side plate, between the two side plates, right?
Mm-hmm. Exactly.
And then your bottom bracket threads into that piece. If the camera will focus, you can see the threads are inside there, and that makes for a really, really solid interface.
Yeah, standard BSA threads.
Yep. Yeah, we're not doing anything crazy there. Super standard. I mean, as with everything, I think the engineering is pretty trick to get to pretty standard stuff.
Exactly. It's really hard to fit everything you need into a bike and to stick with the standard things. I think like a press fit bottom bracket would have been a lot easier for us in a lot of ways, but
yeah, would have been easier design.
Easier design to fit. Yeah, we're a little bit less space that it takes up. So.
Cool. Brad, well, this has been super cool and enlightening. I feel like we're gonna wrap up the shop tour here.
Yeah.
We've kind of gotten around all over Huston Precision, which is sort of also the home of Apogee. So thanks, Colin. Thanks for taking us around and showing us your space.
Thanks for coming by.
We're gonna go ride bikes now in a few minutes.
Yeah.
We're gonna do a little work, a little prep, and then we're gonna get out into the trails that you were talking about.
Yeah,
earlier.
Mr. Toad's Wild Ride.
Mr. Toad's Wild Ride if you're from Tahoe.
Yeah.
First timer here.
Yeah, you'll love it.
It's gonna be fun. Sick. Thanks everybody. Founders Editions. We'll catch you in the next video, the next email. That's Huston Precision.